let's do the last two important parts of this whole chapter, and today we'll do some problems also. So previous lecture was quite easy, okay, there we have a lot of theoretical concepts, okay. Now we will go into numerical parts today. So I hope you are clear with the basic idea of error, okay. Now let's understand some mathematical type of errors which arise whatever calculations we are doing while measurement, okay. What are the different types of mathematical errors which arise, okay. So first, always remember mean, that is very important. Let's define mean. Mean of any n observations. What are observations? Whatever you observe while doing experiments. Let's say you are finding acceleration due to gravity. Let's say you are finding the current in a given circuit, or anything whatever you are finding. Then let's say I did the experiment once and I got the first value as A1. Any value of any experiment, whatever experiment you are doing. Let it be you are measuring the temperature right now. So when I took a thermometer and I found the temperature as A1, first temperature is A1. Let's say the second temperature is A2, third. And let's say I did this experiment 5 times. So these are my 5 outcomes. A1 is the first outcome. A2 is the second outcome. A3 is the third outcome. A4 will be fourth outcome, and A5 is the fifth outcome. I am initially putting only 5. Later we will generalize it for n outcomes. So if these are the 5 outcomes of a given experiment, we can find the average value of this. We call it as A mean. What is A mean? Average value of all these 5 set of outcomes. And that will be A1 plus A2 plus A3 plus A4 plus A5. These are 5 divided by the total 5. We have learnt in 10th standard that our outcome or mean or average of any n data will be the sum of all the datas divided by the number of datas, correct? So A1 plus A2 plus A3 plus A4 plus A5 divided by 5. Great. What if there were 10 data, 10 outcomes? Then we will add all the 10 outcomes and divide it with 10. That will be our mean or average. Now, don't get confused. Sometimes they use this word also, average also, in the problems. So you should not get confused. So this is the average value of these 5 outcomes. If there are n outcomes, then what will be the average? So let's generalize this. If A1, A2, A3, there are an outcomes of a given experiment, then the average or the mean outcome will be A mean, that is equals to A1 plus A2 plus A3 plus an whole divided by n. A mean will be equals to the sum of all the outcomes divided by the total number of outcomes. This is called the mean. Okay. Let's define the first mathematical error, and that is called as absolute error. Absolute error. How do we define this absolute error? We define this absolute error as a delta A1. Delta A1 is what? What is delta? Delta is just a symbol that tells you that this is absolute error. This is just a notation. Don't get confused with this sign delta. Okay. Wherever this delta will have a different meanings, I will tell that as we will move on with the course. Initially, here it simply represents absolute error. So delta A1 will be absolute error in the first outcome. That is delta A1. That is A mean minus A1. The absolute error in the second outcome will be A mean minus A2. Similarly, the absolute error in A3 will be A mean minus A3. Now, if you have n outcomes, then there will be n absolute errors in each individual outcome. So, delta A mean An will be equals to A mean minus An. I hope this is clear. Any doubt up till here? Okay. So these are your absolute errors in each reading or each outcome when you are performing some experiment. Let's define another parameter. I'll do a numerical also at the end that will clear this whole concept. And this is our mean absolute or average absolute error. Mean absolute error. Now mean absolute error is denoted by delta A mean. Delta A mean. And that will be equals to the absolute error in the first one. But be very careful, we keep a modulus sign. Modulus sign means we don't take the negative values. We only take the positive values. I'll do numerical, then you will be clear with this thing. So delta A1 plus delta A2 plus delta A3 plus delta AN whole divided by N. This is called as absolute mean error, mean absolute error. Okay. When you add all the absolute errors and divide it with the total number of outcomes, you get mean absolute error. Similarly, let's define another parameter, and that is called as relative error. As the name suggests, relative. Relative means with respect to something. Ratio. This relative error is the ratio of delta A mean, mean absolute error, and the mean. That is called relative error. Now there are different words which are used. Relative error is also known as fractional error. So in school very few teachers tell this, and in exam they give this. Find the fractional error. Fractional error is same as relative error. Fraction it is. We know what are fractions, right? So delta A mean divided by A mean is called as relative or fractional error. Finally, last is percentage error. Percentage error. Now we know how to calculate percentage. So percentage error is simply relative error into 100. That is delta A mean whole divided by A mean into 100. This is called our percentage error. How do we calculate percentage? By simply finding the ratio or the fraction multiplied with 100. This is called your percentage error. So let's do one numerical and understand all these types of errors in a realistic way. Okay. So let me remove this whole thing. So let's deal with our first problem. Okay. I'll make it quite easy, but I will tell you at the end what type of questions they will give you in exams. So focus on this to clear this concept of what we have just now understood. Okay. In an experiment of measuring the temperatures of a given object, we found that the temperature was measured as 10 degrees Celsius, 15 degrees Celsius or 15 degree Kelvin, whatever you want to take it. Next is then 10 again, third attempt, fourth attempt 20 degrees Celsius, and fifth attempt again 10. Okay, and let me take one more. Okay, leave it. So these are the 5 outcomes of a given experiment. I did an experiment of measuring the temperature. When first time I measured the temperature, my thermometer gave the temperature as 10 degrees Celsius. When I did the experiment again, I got it 15 degrees Celsius. When I did it for the third time, it gave me 10 degree again, fourth time 20 degree, and fifth time finally 10 degree. So the question is, calculate the percentage error. Okay, now you can see there is a lot of error. Why? Because it seems the temperature is close to 10, but there is an error over here and error over here. Means you are getting double the actual temperature. Okay, sir, how do you know that the actual temperature is close to 10? Because you can see that 10 is repeated thrice. Okay, which means 10 must be, means closer to 10 it must be. Okay, so our outcomes here for this experiment is A1, A2, A3, A4 and A5. These are the outcomes when I did 5 times the same experiment. Let's calculate the mean of this particular experiment. So mean will be how much? 10 plus 15 plus 10 plus 20 plus 10 whole divided by how many times I did the experiment? 5 times. So this will be the mean of all these values. So let's directly solve it. 10 plus 10 20, 20 plus 10 30, 30 and 20 50, 50 and 10, 65. 65 by 5. And 65 divided by 5 is nothing but 13. So this 13 is a very important value when you are performing realistic experiments in physics lab, okay? This 13 is that value which is close to the actual value of the given system. So this is mean. Now what we will do next? This is our mean value of this experiment. Now we will find the absolute errors, because question says find the percentage error. If you are asked with percentage error, you have to first find absolute error, then mean absolute error, then relative error, and finally percentage error. So let's first find the absolute error in the reading 1. Be careful, this delta represents absolute error. Because A1 is already 10. We can't write absolute error as A1 only, because A1 we have given it to 10. So delta A1 will be 13 minus 10. A mean minus A1, which is 3. What is the absolute error in the second reading? Second reading has 13 minus 15. This is equals to minus 2. I am writing here negative 2, but when I will find the mean value, mean absolute error, in that case I will not take this negative sign. There I'll explain this again. Right now I am just writing what are the absolute errors in individual readings. So delta A3, that will be 13 minus 10, once again 3. Delta A4 will be error in fourth reading, which is 13 minus 20, which is minus 7. And finally delta A5, that is the error in final reading, 13 minus 10, which is 3. Now once you have found your all the absolute errors, let's find delta A mean. What is delta A mean? Mean absolute error. And mean absolute error means magnitude of 3 plus magnitude of minus 2 plus magnitude of 3, okay, plus magnitude of minus 7 plus magnitude of 3, whole divided by how many readings? 5 readings. So what is the meaning of these vertical bars? In case if you are not familiar or if you have not seen these vertical bars, okay, you will understand this absolute value function in second chapter of maths, relations functions. Your teachers will tell you. So this is also called as modulus function. Some teachers call it as absolute value function. This always returns positive value. So 3, why it returns positive value? That you will be doing in maths. So it will be 3 plus this negative sign will convert into positive. Why it is converted? Why it is giving us? Again in maths. Plus 3 plus 7 plus 3 whole divided by 5. I hope this is clear. Let's add 3 plus 5, 3 plus 2 5, 5 plus 3 8, 8 plus 7 15, 15 plus 3 18, 18 divided by 5. That will give us 3.6. Let me repeat again. 3 plus 2 5, 5 plus 3 8, 8 plus 7 15, 15 and 3 18, 18 divided by 5 is 3.6. Yeah. So what we have done till now? First we calculated the mean. If you know the mean, you can calculate the individual absolute errors. Once you have calculated the absolute errors, you have found the mean absolute error. Once you have found the mean absolute error, now you can define relative errors. Relative error. Now what is relative error? Relative error, let me repeat again, it's the ratio of mean absolute error divided by mean. So mean absolute error here is 3.6 and mean, as you can see here, it is 13, so divided by 13. So it is 3.6 divided by 13, that is equal to nearly 0.27. Let me write it, or let me make it 27, not 27, let me make it 28, because the next digit is greater than 5, so 0.28. So what is the relative error? 0.28. So what will be the percentage error in this data? That is 28%. 28% is the percentage error of this whole data. This is the way we calculate percentage error. Very simple. Okay. Now, sir, will they give us values like this? No. Okay, they will not give you values like this in your exams. In your exams you will get values like this: 1.23, 2.57 and 3.25. so you have to be very careful with the calculations. Formulas are very easy. Most of the students, they do this wrong with the calculation part because of these decimal points. Okay, I have done this very simple because to make you clear with this thing. So this is very simple. You have a particular process. The process is, whenever you are given with any outcomes, first task is to find the mean. Once you have found the mean, next step is absolute errors. Once you have found absolute error, find mean absolute error or average absolute error, as they say in exam sometimes. Average, mean is same as average. Then you have to find relative error. Now sometimes they use this word relative as fractional, as I said earlier. So fractional error you have to find. And finally, after relative or fractional error, finally you have to find percentage error. So sir, the basic idea is, if they ask us percentage error, do you mean that you have to solve each and every step and then reach up to percentage error? Yes. Great. What if they ask us mean absolute error? Then you have to find mean absolute error and do up till here and then stop. You don't have to find relative and percentage error. I hope this is clear. So this is a chain. If they are asking percentage error, you have to follow each and every one. This was quite easy part of errors. Let's move to a little realistic or quite important part of errors, and important, that is propagation of errors. And this will be required a lot when I will be solving, after this chapter gets over, a question bank. Okay, so where I will be solving questions related to all the possible, like previous year's questions, possible problems. Okay, one type mostly from this chapter. There you will require this a lot. So propagation of error is very important. Then those stuff, percentage error and all. But you should know those things: percentage error, absolute error, okay, all these things, so that you can understand this propagation of error. Now, what do you mean by propagation? Propagation means motion. Okay, sir, motion means what? Error move? Yes, error can be propagated. Propagated means, if let's say I have given you a cardboard, a wooden cardboard, and I gave you a meter scale. That meter scale gives always a wrong answer. There is some error in that meter scale. It always gives us a wrong answer. Then if I give you this cardboard and that meter scale, and I ask you to figure out length and the breadth of this cardboard, can you figure it out? Yes, you will get it, but that length and that breadth will always have some error. And whatever error there is in the length measured by you using that meter scale, and whatever error the breadth has, okay, whatever you measured, that will propagate. That error will propagate if I ask you to figure out the area. Correct? So if length has some error, if breadth has some error while performing the experiment, the area will also have some error. True? Yes. Similarly, if I give you a cuboid, and if I give you a meter scale which is not perfect, and if I ask you to figure out the length of this cuboid, the width of this cuboid, and the height of this cuboid, you found the length, you found the breadth, and you found the height, let's say. Each length, breadth and height has some error. And if I ask you to figure out the volume, will this volume will have some error? Of course. So such error which goes from length, breadth and height to the volume, we call it as propagation of error. The error went from length, breadth, because what were the measured quantities? Length and breadth. You didn't directly found the volume. You found the length and breadth. Now volume is dependent on length and breadth, okay, and height. The error propagated to that. So propagation of error will have different quantities. We will understand that. But before we go into propagation of error, let's write any physical quantity. So let's say if length is our measured quantity, then we can write length plus minus delta L. Sir, what is delta L? Delta L is representing the error measured in the length. Sir, why plus minus? Plus minus because you can have error plus also and you can have error minus also. Sir, give a realistic example. A realistic example is, let's say there is a stick, okay, a wooden stick, and I gave you a meter scale and I asked you that to measure this stick. Now, you measured it as 10 centimeter. You measured the stick AB as of 10 centimeter. But then I told you that this meter scale has an error of 0.5 centimeter. Now your answer can be 10.5 also, depending on that meter scale is less by 0.5, or your answer can be 9.5 also, depending on if it measures extra 0.5. So it depends on the error of the instrument. So error can be positive, it can be negative also. So L is your actual value of the length measured by you, and delta L represents the error in L. Similarly, all the physical quantities in physics, we can take it like this. If I am measuring the time t plus minus delta t, anything. So now I am not specifically talking about length, time or mass or anything, okay. Let's take our physical quantity A. It has some error plus minus delta A. Another physical quantity B, which has an error of plus minus delta B. These are two physical quantities which I have measured. You can think of it as, if you want to make it simple, you can think of it as A is your length and B is your width or breadth. Okay. Where delta A represents error in A, measured quantity A. Delta B represents error in measured quantity B. I hope this is clear. Delta A is the error in A and delta B is the error in B. Now, if you are adding these two, if you are adding both the quantities, like if you want to find, like this has the length of A, this is your A, okay, and this is your B, and you are asked with the perimeter of this rectangular cardboard, then what you will do? Sir, first we found the length, then we found the width. Now we have to use the formula 2 into L plus B. So L plus B, when you are adding length and breadth, your error will be propagated to the perimeter. Now you can't find directly perimeter, means you have other means, but the thing is, if you are given with only meter scale and they are asking you to figure out the perimeter of the cardboard, in that case you are adding A with B. So in addition, let's say we are getting the final quantity as Z. This Z is having some error delta Z. So what does it mean? It means that if you are adding A and, one second, let me rewrite it. Yes, A to delta A plus B plus minus delta B. Try to understand this equation. This equation says that if you are adding A having error in it and adding with B having error in it, then you will get a final quantity Z which has some error. So simple. You have a quantity, measured quantity A, which has some error in A. B is the another quantity which has error in B. And when you add both the quantities, you will get a final quantity Z which has some error in it, which is represented by delta Z. So what is Z? Z is the final summation, the perimeter you will get finally, like just an example of perimeter. But Z is the total sum of both the quantities A and B. And what is delta Z? It's the error of both delta A and delta B. So when you add two quantities having errors, you will get a final quantity which also will contain error. That is obvious. So you can't write here simply z. You will have to put a error in it because z is the final summation of these two quantities. Even for subtraction, addition, even for subtraction here, instead of plus, you will have minus here. So when you are subtracting, again in that case, delta z will have some error. When you are subtracting two quantities, having error in it, you will get a final quantity which will also have some error in it. So this is your addition and subtraction. Let's see what happens if you are having two quantities which has multiplication and division. Multiplication or division. So we will start with multiplication and we will end up with division. So multiplication or division. Now this is, I am putting here star because on this majority of questions they ask in competitive exam as well as in your school exams. Okay, so this is something very important. Means something which you have to do. Okay, you can't skip this part. This is something really very important. Multiplication and division. Where do we do multiplication or division? If we have to find the area, let's say. If I have a cardboard having length L plus delta L and breadth B plus minus delta B, then area will be length into breadth. So what will be the error in the area? We will solve numericals on it, most probably in the next lecture. So focus on this. So here A is the first quantity. Pay attention, this is a quite important derivation also. A is the first measured quantity with delta A as the error inside it, and B is the second measured quantity with delta B error in it. Now if you multiply both of them, you get a final quantity which is Z, which has an error of delta Z. Let's multiply them and check what we get. So here it will be A multiply. How do we multiply two brackets? Multiply A with this and multiply A with this. Then delta A with this and delta A with this. Correct? So these are your method of multiplication, simple multiplication for two brackets. So it will be A into B plus minus A into delta B plus minus delta A into B plus minus delta A delta B. Now be very careful. Many students, they get confused with this delta A delta B notations. Let's take a realistic example here to understand this so that you can understand how we proceed here. So let's say this length is 5 centimeter and this width is of 3 centimeter. And error here is plus minus or 0.1, and here also plus minus let's say 0.2. Okay, just an example, random example. So what will be your length? Your length is A, let me call it as A, and this is your delta A, so that you don't get confused. You can compare it when I will solve this derivation. And B is here and this is delta B. Okay, let's proceed with the derivation. So one thing is clear, if I divide this whole thing with Z, what is Z? Z is the area. So what is the actual value of area Z? This is A into B. Z is always A into B. What will be delta Z? That we have to find. Let me repeat again, Z will be simply A into B. You can compare here with the cardboard. If 5 centimeter is the length and 3 is the width, then what will be the area? 5 3 is a 15. Now that 15 will have some error in it. That will depend on delta A and delta B. So Z equals to A dot B. Let's divide this whole equation with Z. So this will be plus minus delta Z by, Z by Z, delta Z by Z. That will be equals to A dot B by Z. Be very careful, I am dividing left hand side as well as I am dividing the right hand side with Z. Plus minus delta A by A B by Z and plus minus delta A delta B whole divided by Z. I hope this is clear. I divided the whole blue equation with Z. Now what's Z? Here Z by Z is 1 plus minus delta Z by Z equals to, what is Z? So z is a dot b, written in the green box you can see on the screen. So it will be a dot b plus minus a delta b upon ab plus minus delta a b upon ab plus minus delta a delta b whole divided by ab. I hope this is clear. Since z was ab, I divided on the right hand side everything with ab. So this will be 1 plus minus delta z by z. ab upon ab, this whole thing will cancel out. Yes, I left with 1 plus minus. Now pay attention here. Many students, they get confused here. When I cancel a with a, students say, sir, why don't you cancel b and that b? Be very careful. This is delta b. Is your delta b equal to b? No. b is 3 over here and delta b is 0.2. How can you cancel these two terms? Delta a is 0.1 and a is 5. Can you cancel these two terms? No, you can't. So be careful. You can cancel a with a, yes, but can you cancel delta b with b? No. Similarly, in the second one here, b with b you can cancel, but can you cancel delta a with a? No. And finally, you left with delta a, delta b whole divided by ab. This 1 cancels with 1. Okay. Since our course started now, okay, so this is our first chapter. This is the first approximation, and this is very crucial approximation which we will take again and again throughout this course till 12th standard. What is this approximation? Pay attention. Very, very important. If delta a, like in this example, let me minimize and show you together. Delta a here is 0.1. Delta a, what I took? 0.1. Okay, you can take any value of your choice. And delta b here is how much? 0.2. A is 5 and b is 3. Sir, can you have delta a greater than a? No, no, you can't. How can you have error so large greater than your measured outcome? Never. It's like, sir, temperature is 10 degrees Celsius and error is 100 degrees Celsius. That's useless, okay? You can't have error greater than your actual physical quantity, no? Okay. If it is so, then you are doing completely like, that's useless stuff, okay? Delta b, can it be greater than b? No, never. So, delta a into delta b, this is very important. Delta a into delta b is 0.1 into 0.2. Now, when you multiply this, you will get what? 0.02. I am solving it, but you can assume this for other quantities also. You can take different values and check. When you multiply delta a with delta b, you will get a very small value. But if you multiply a with b, you will get a very large value compared to the a and b. See, 15 is much greater than a and much greater than b also. So, when you are multiplying a into b, you are getting a number much greater than a and b itself. But when you are multiplying delta a and delta b, you are getting much smaller number. So, when you divide a much smaller number with very large number, let me repeat, when you divide a small number with a very large number, you will get what? Sir, we will get much smaller number. So, give an example. Example can be divide 1 by 1000. 1 is very small and 1000 is very large. 1 by 1 million, okay, 10 to the power 6, much smaller. So, be very careful. If you are dividing a small number with a large number, the overall value will be negligible. So, I am putting it in a circle and I am writing here it's negligible. Okay, and such assumption not, I have proven it, okay, right now, but they will, I don't know if in your school they will teach you, but right now you have to keep in mind that why they neglect this. They neglect it because the overall outcome is very small. So, what you left with? You left with one of the very beautiful equations, equation of this first chapter, and that will be useful while solving many problems. So, plus minus delta a by a plus minus delta b by b. Delta b by b. So, this is your error propagation while multiplication or division. We will do some problems, okay, I'll take into account right now, okay, few questions. Let me repeat again, delta z is the error in z. Z is the measured quantity, delta A is the error in A is the measured quantity, and delta B is the error in B, and B is the measured quantity. Okay. Now let's do one more, then we will go for a numerical based on multiplication and division and also other problems. Okay. So here it is, if something is in square, for example, if they give you find the area of a square. Now rectangle length was different from breadth, but here the length is also equal to the breadth, so A is equal to B. In that case, we can directly modify that B will be equals to A only. So delta Z by Z, the error in Z or the area plus minus, that will be equals to plus minus delta A upon A. And B is also A in that case because it's a square, right? So square has same sides. Delta A upon A. So this implies plus minus delta Z upon Z, that will be equals to plus minus 2 times delta A upon A. Okay, so roughly speaking, if there is any quantity like find the volume of a cube. So cube is what? Volume cube is length cube. So what will be the error? Error will be plus minus error in volume upon the volume will be equals to 3 times error in length upon the original length. Done. This will be your relation. So power, as the power increases, this power will come in front. That's it. But this is something very, very important formula.